Okay, so now let's solve this problem, this example, and this is a case of 3 by 3 problem. So basic formulas is, this is the shape of the differential equation, this is the proposed solution, this is the equation to find the values of lambda, and this is the equation to find the values of k vector, the eigenvector and the eigenvalue. Now this is a case of 3 by 3. This is a very long problem, so I may not have a space for to find the three solutions, because now this is 3 by 3, meaning that we have to find three solutions. So let's see if we can find, if we have a space to find at least the first solution. Okay, so we start with this, the determinant of a matrix. Now this is 3 by 3 engineers, so it's going to be minus 4, 1, 1, 1, 5, minus 1, 0, 1, minus 3, minus lambda, the identity matrix. In this case, for 3 by 3, is going to be 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, and this must be equal to 0. Okay, so I'm going to jump directly to the determinant. So it's going to be minus 4 minus lambda, and then 1 and 1, 1, 5 minus lambda, and then minus 1, 0, 1, minus 3 minus lambda. On the exercises, you can jump directly to this determinant. I don't usually write this. I jump directly to the determinant, and the only difference between the determinant and the A matrix is just in the main diagonal. You have minus 4 minus lambda, 5 minus lambda, and minus 3 minus lambda, and that's the only difference. And you have to make this equal to 0. Okay, so what we have to do is resolve the determinant. I usually use the cofactors method, which means you choose this minus 4 minus lambda, and then this times this and this times this, 5 minus lambda and minus 3 minus lambda, and then plus 1 in this case, because up, and then minus, I eliminate this column and this row, and I get minus 1 times this and this times this. Minus 3 minus lambda, this 1 times minus 3 minus lambda, and then minus 1. Minus 1. And that should be equal to 0. Now, the next will be the third, this and this. But because this is 0, then it doesn't count. And this should be equal to 0 according to the formula. Okay, now, what we have to do is to try to reduce this. From here, I can see minus 4 minus lambda times, I'm going to develop this binomial, minus 15, and then minus 5 lambda, plus 3 lambda, plus lambda squared, and then plus 1 here. And from here, it is going to be minus, check this out, minus 3 and minus 1, it is minus 4 minus lambda, equal to 0. Now, usually this minus and minus will become 0, but check that this is the same as this one. So we can do a factorization. So what will be the factorization? Minus 4 minus lambda times this number. Let's write first the lambda square, and then minus 2 lambda, and then minus 15 and 1, minus 14. And now, because you factorize this number, then minus 1 equal to 0. Now, from here I can see what is the first value of lambda. Lambda 1 is equal to minus 4 from this fraction, okay? If I replace the minus 4 here, this becomes positive, and then this is 0. The only thing left is the other one. Now, this minus 14 minus 1 is going to be minus 15. Okay, now, tell me two numbers in which the multiplication is minus 2. Sorry, the multiplication is minus 15, and the addition is minus 2. What about minus 5 plus 3? This times this, minus 15, and the addition minus 2. So I can see that the lambda 2 is equal to 5, and lambda 3 is equal to minus 3. Alright, so we found the values of lambdas. And we found 3, because it is going to be 3 by 3. And because it is 3 by 3, we have to find 3 solutions. Okay, now, they happen to be real real different roots. In the next videos we will see what happens if they are repeated roots and when we have imaginary roots. Okay, now let's follow the process. By the way, the order doesn't matter. You can find lambda 1 minus 3 or you can find lambda 1 5 in the different order. The order doesn't matter. You will get the same solutions, just in different order, but that is not important. Okay, so now we found the values of lambda here. Now let's find the values of k vector. Because of the space, I may only find the first one, but the procedure will be the same for the other two. Alright, now let's use this one first, and let's use this equation. So the matrix is going to be minus 4, 1, 1, 1, 5, minus 1. I am here, then 0, 1, minus 3, minus lambda, the value of lambda in this case minus 4. I replace the value minus 4, and then the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 times k vector here, k1, k2, k3 equal to 0 vector 0, 0, 0. Okay, engineers, I usually don't write this. What I write is just the system of equations, and the system of equations will be something like this. Minus 4 plus 4, 0. And the other doesn't affect because they are zeros. 1, 1. And then 1 and 0 is just 1. And then 5 minus 4 is going to be 9. And then minus 1. And then 0, 1, minus 3 plus 4, just plus 1. Okay? 0, 0, 0. Okay, I don't have to write all this. It's just the 0 vector and then the multiplications here. Now, as you can see here, this matrix is actually this matrix, but you replace the value of lambda of minus 4. So minus 4 minus 4, 0. And then 1 and 1, 1 and minus 1, and this 0 and 1. The only that affect is these values, the main diagonal, but you replace the value of lambda, in this case minus 4, so this becomes 9, and here becomes plus 1. Okay, the next step is to make the step matrix. So what I'm going to do here is just to interchange row 1 with row 2. Okay, so what happens? 1, 9, minus 1, so this row goes up, and then 0, 0, 0. The 0, well, this column, because they are zeros, it doesn't matter what kind of operations you do here, you always get zeros. And then 0, 1, 1, 0, 1, 1. Okay, what I'm going to do here, because I want to do a step matrix, this is the first step. Now we have to make this 0 to have the second step. In Spanish that is called escalonamiento. But anyway, now let's do minus the row 2 plus the row 3 and we save in the row 3. We try to make this 0 and we are going to use the number in the second row. Okay, so what is the result of that? So it's going to be the first row, it doesn't change, 1, 9, minus 1, 0, and then 0, 1, 1, 0. The second row doesn't change because we are affecting the row 3. Okay, now 0, so now minus 1 plus 1, 0, minus 1 plus 1, 0, and this is 0. Now, again, just as I said before in the previous video, this should happen, this shall happen. If this doesn't happen, then you did something wrong. This should always happen. Okay, now, what is the equations? The equations left are k1 plus 9k2 minus k3 equals 0. And then k2 plus k3 equals 0. Now, this is each column is the values of k1, k2, and k3 from here, k1, k2, and k3. Okay, so now let's give a value of k3, or we can give a value to k2. All right. I will choose k3 equal to something, but you cannot choose k equal to 0, because if you choose k equal to 0, your k vector will be 0. If your k vector is 0, then you don't have solutions. Okay, so let's choose k3 just for the sake of making something easy, k3 equal to 1. So what happens to the equations? In this case, for this one, k2 is equal to minus k3, so that means is equal to minus 1. So you got k3 and k2. Now for the k1 is going to be k1 plus 9 k2, which is minus 1, minus k3, which is just 1, equal to 0. So minus 1 and minus 1 is going to be minus 10. To the other side, k1 is equal to 10. Okay, so what you have here is the k vector. 10 for k1 and k2 is equal to minus 1 and k3 is equal to 1. Okay? Now, what happens if you choose another number? Okay, if you choose another number, let's say that you choose k3 equal to, let's say, minus 1, then k2 will be minus 1 here. If this is minus 1, then minus and minus will become positive 1. And because of this, then this is going to be k3 is equal to minus 1, so this becomes positive, and this is positive, so it's going to be 9 plus 1, which is 10, so k1 is equal to minus 10. So what is the result of k vector? Well, it is equal to minus 10, 1, and minus 1. And check, what is the difference between this and this? What is the difference? Well, it is actually the same vector, it's just in the opposite direction. Here positive, positive, and then negative, positive, negative. So what you found is just this vector, but then in the with k, with this value, with 1, and with the other value you just found in the opposite direction. But what matters here is not the direction, is not the sense, if it's go up or down. What matters is the direction. Alright, now what happens if you choose, let's say, another number? What happens if you choose, let's say, 2? k3 is equal to 2. So what happens here? 2 minus 2 here, and what happens here is going to be k1 plus 9 k2, in this case minus 2, and then minus k3, which is 2, and then is equal to 0. So k1 is equal to what? Minus 18, then is plus 18, and then minus 2 to the other side, plus 2, so it's just 20. So what is the result? 20 minus 2 plus, and then 2 here. But what is the relationship between this and this? Well, it's just twice. So in the end, it's just 2 times 10 minus 1 and 1, which is exactly the same vector. So what you find is first this, and then you just found twice the size of that vector. Okay, so what matters here is, again, is not how big or if it is in the other direction. What matters here is the direction. Okay, so in here, that is why I choose an easy number, so we got the same result, but you can choose whatever number. The end result is just you are going to find a bigger vector or a smaller vector, but that is the difference. On the examination, on the examples, I will check if it is a multiplier of the solution. Okay, that was just a comment, because you can find different values of vectors, but in the end it is the same vector. Okay, okay, it was just a comment because many students get different results, thinking that one is wrong and the other is right, but in the end they don't realize that their results are just multipliers of the same result. Okay, now what is the result? In the end, the first row, the first solution is going to be my k vector, 10 minus 1 and 1, exponential of, I am using this formula, k vector lambda, and the lambda that I use is minus 40. And this is only my first solution. I have to repeat the same process, but now with lambda equal to 5. So in the end, what happens here is that you will choose here 5, and then you have the equations, and this should happen again, and then you choose a value of one of the k's to get the vector. And then again the process, but now with lambda equal to minus 3, so you replace the value of minus 3 here. The only difference that is changing is the number of value here, and then you make the step matrix, and you should get this again. If you don't get this, rows, this row of zeros, then you did something wrong. But in the end, you will find the second solution and the third solution, and the final general solution will be C1 x1 vector plus C2 x2 vector plus C3 x3 vector, and that's it in years. Unfortunately, I don't have the space to find the other two, but the procedure is actually the same. On the next video, we will see how to deal with when you have repeated roots. Okay, see you.